Question 1. Write the sum of 12 radical 23x to the 13th plus 14 radical 23x to the 13th in simplest form. So the first thing that I will notice is I will notice that everything underneath the radical is identical. Those are called the radicands. The radicands are identical. So since they are identical, we can just add the coefficients out front. So 12 plus 14 gives us 26 radical 23x to the 13th. So it's the exact same idea as what's 12x plus 14x. 12x plus 14x is 26x. So in this case, instead of just x, we have the entire radicand. We need to write 23x to the 13th. We're not quite finished though, because the problem says to put this in simplest form. We cannot take the square root of 23, nor is there a perfect square that goes into 23 evenly. However, we can rewrite x to the 13th. So with variables with exponents, recall it needs to be an evened number exponent to be able to take the square root of it. So what we're going to do is we're going to rewrite x to the 13th as x to the 12th times x to the 1st. Because x to the 12th times x to the 1st is x to the 13th. Now we can take the square root of just x to the 12th. The square root of x to the 12th is x to the 6th. And that's because x to the 6th times x to the 6th is x to the 12th. We cannot take the square root of 23, so it stays underneath the radical, and we cannot take the square root of a regular x, so it stays under the radical, and this is our final answer.